Okay, so the big test review. So 216. We look on our sheet and find out that 216 is not a perfect square. So we try to find out which number that goes into it. So pretty much you just start, half of 216 is 108. So basically you want to start below 108. Obviously 100 does not go in, so let's try dividing by 81. 216 divided by 81. I'm just doing this with the calculator. I get a decimal. How about 216 divided by 64? Still a decimal. How about 216 divided by 49? This is all you do. Being a math teacher doesn't mean you know all the answers. 216 divided by 36. And there it is. This is radical 36 times radical 6. Square root of 36 is 6. Radical 6 days. And that's your answer. Negative 80. Well, hopefully you recognize that 4 obviously goes into 80. But that would leave you 20. And there's a 4 in 20. And 4 times 4 is 16. So this actually breaks down to, don't forget the negative 1. Then it's going to be 16 times 5. All of those. All 3. 5 times 16 is 80 times negative 1. So the negative 1 is going to come out as I. The 16 is going to come out as a 4, but don't forget this 2. The 5 stays. But it's not 4i radical 5. It's 4 times 2. 8i radical 5. Here we do outside and inside. So we get negative 18 on the outside, and on the inside we have 14 times 28, which is 392. And then once again, we just take our calculator and try to figure out what goes into it. Now 392 divided by 2 is 196. Hey, 196 is on our list. It's 14 squared. So this breaks down to 196 times 2. The square root of 196 is 14, but don't forget we have to multiply it by this. So the radical 2 is going to be stuck inside. But this 14 times 18 is negative 252.
Have a quick slight correction. Apparently your paper, different version, has a negative here. It's negative 14 under the radical. So that would mean we'd be dealing with a negative 196. Remember, or some of you like to put negative 1, but I put it with the perfect square, which means then we're going to be pulling out an I. So this should be negative 252i square root of 2.
Okay, over here. I'm going to do outside and outside. I'm going to show you a different method here. You could do this and get 10 and then 18 times 45, which would be a big number. But you can also recognize this has a 9 and a 2. And this has a 9 and a 5. And you can break those numbers down smaller. The square root of 9 is 3. Don't forget this. 3 times 5 is 15 root 2. Times square root of 9 is 3 root 5. Now I can do smaller numbers on the inside and not have to worry about breaking them down. 45 times radical 10.
And one more quick correction. Silly mistake here. I circled my 5 to remind myself of this, but I forgot to circle the 2. So this 3 came out and should multiply by the 2, which would have given me 6 here. And thereby 6 times 6 times 15 would give me 90. Square root of 10. So just another slight correction. That's it.
Now, again, I would have gotten the same answer if I did it the other way. just might have taken me a little bit longer to break down the bigger number of 810. Possibly not, but it's just an option on how to go about solving those. Okay, factoring. Well, these are not all even, so I cannot divide out the 2. I'm going to identify A, B, and C first, always. 2, 7, a funky looking 7, negative 30. I'm going to do my ABC method. 2 times negative 30 is negative 60, and B is 7 down here. So I need 2 numbers that make 60 that differ by 7. Because one's going to be positive, one's going to be negative. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12. And there's our winner. So we're going to have a 5 and a 12. Since this is positive, I want the 12 to be positive and that to be negative. So I'm going to rewrite now 2x squared. And I can write either negative 5x plus 12x. I'm going to put the 12 first, just because it has something to factor with the 2. Minus 5x minus 30. Those are going to have something in common. Now remember, all I did was rewrite 7x as 12x minus 5x. I'm going the opposite of FOILing. So I'm going to group these two. I'm going to group these two. I'm going to divide by 2 here and divide by x and get x plus 6. I get to cheat. I get to say, hey, I know this has to be x plus 6 because this has to be the same. So what do I divide by now? This helps me decide whether to divide by a positive 5 or negative 5. And it's going to be a negative 5. Okay, so on number 6, there are 2 options here. And the 2 options are, you could factor this right now because this is all perfect squares. And a 2x plus 5, 2x minus 5. Sorry, 10. But if you notice, they're both factorable by 2. And then you simplify it like this. To save that hassle, what we always say our first step was to pull out the DCF. Now if we do that, we have x squared minus 25, which then takes us to our answer just a little bit quicker and a little more efficiently. Okay, so number 7, ABC method. 6, negative 23, and 20. 6 times 20 is 120, and this is negative 23. Now since the 120 is positive, that means you're going to add up to this number. Since it's a negative, they have to both be negative numbers. So I start looking at my numbers, 1, 20, and 1, 2 and 60, 3 and 40. I'm just using the calculator if I need to. 4 and 30, 5 and 24, 6 and 20, 7 doesn't work, then you have 8 and 15, and there's your winner. So then what we do is rewrite it, 6x squared. We're going to bust up the negative 23 into negative 8x and negative 15x, and then just a plus 20. Then we group them together in pairs, take out what we can. 2x gives us 3x minus 4. We cheat, right? 3x minus 4 right here. What are we going to divide by to get 3? Or we're going to divide by negative 5. Hook them up. 2x minus 5, 3x plus 4, finish. Perfect square, perfect square. The difference is it's not subtraction, it's addition. But guess what? It's the same format. One's going to be plus and one's going to be minus. You take the square root of the first term, and you take the square root of the second term. The only difference is when you have a sum of 2 squares, we add the I. And that's it. We're finished. Okay. I do the 11th. Now, if you've been having trouble with this still, let's break it down with a small one. It's easier to do. Every 4 i's, this is really I, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? It's I times I times I 11 times. But remember, every group of 4 is 1. So that's 1 times 1 times these, I cubed. Well, 1 times 1 is just 1, so really we're just looking at I cubed. And that is negative I, and we're finished. Now, quick side note. You do have to have these memorized. But look, here's how easy it is. There's only 1, 2, 3, and 4. You all pretty much know that anything to the first is itself. And we've talked about over and over that I to the fourth is 1. And everybody's pretty good with the idea of, 25, negative 25, no I there, negative 25 breaks down as 5i. Because the square root of negative 1 is I. So I squared is negative 1. I think everybody's got a pretty good handle on that. Well, let's think about this. X to the first times x squared equals x to the third. Well, guess what? I to the first times I to the second equals I to the 3. Well, what is I to the first? Well, it's just I. What's I squared? It's negative 1. And what is negative 1 times I? Negative I. So even if you forget, you can, from what you already know, you can figure out what I cubed is. That's one that most people forget, if they're going to forget any of them. Back to our problems.
Okay, well, another change to this one, your study guide had a 7 here. So therefore, we're going to divide 42 by 4. That's going to be 10. 10 times 4 is 40. So we're going to throw these 40 i's away because they're all 1. That's going to leave 2. So that's I squared with a 7 in front. Since I squared is negative 1, that means negative 1 times 7, so that's negative 7 for our final answer.
7 is negative 14. I times I is I squared. Remember what I've said, though, I like to put that in parentheses and put a little negative 1 underneath it to remind myself what it is. And then this really just means times, so it ends up being positive 14. It changes the sign of the negative 14.
Okay, another slight correction on your paper. This one is a minus 2i, no plus. So you're still going to distribute the negative sign. So that's going to be 3 minus 5i. Now the 6 is going to become minus 6. And minus negative 2i is going to be plus 2i. So now we're going to combine like terms. And 3 minus 6 is negative 3. And then negative 5i plus 2i is going to be negative 3i. And that's our answer.
This distributing 8i times 4. Same thing as if this was 8x times 4 minus 3x. What will we do? We get 32x minus 24x squared. The only difference is when we do it here, we still get 32i, and we get a negative 24i squared. But in this case, remember, I squared has a special ability of being a negative 1, which is going to make the negative 24 become positive. And remember, you can take the step of doing this if you need to. But remember to rewrite it in this format, a plus bi. You could go from here to there directly, it's up to you. 14, we're foiling. First, 10. Outer, plus 18i. Inner, minus 15i. Last, minus 27i squared. Again, parentheses, negative 1. This negative 1 is going to make the negative 27 positive. If you need to write that out, you can, or if you just want to add that right to the 10 and do that right now, put the number in front, you can. And then 18i's minus 15i's is plus 3i. Complete. 15.
Okay, another correction. On number 15, your paper has 4 minus I instead of I minus 4. So we're still going to multiply by the conjugate, which is 4 plus I over 4 plus I. Remember, you multiply by the exact same thing as the denominator, just change the sign. Now, here, we're going to distribute the 9. So 9 times 4 is 36. 9 times I is just 9i. On the bottom, we'll have Florida. 4 times 4, didn't mean to do that, so let's make this into a 6. 1, so 4 times 4 is 16. Minus times the positive is negative, and we have I squared. But remember, this quantity is really a negative 1. So what we're saying is 16 minus negative 1, which is 17. And that's your new denominator. And the numerator stays 36 plus 9i. Final answer.
Okay, same idea. I want to multiply by 2 minus 5i, but I have to do that on top and bottom. Only difference is here I am foiling on the top. So I end up getting 6 outer, 2 times 36, outer, 3 times negative 5i is negative 15i. Inner, 2 times I. Last, negative 5i squared, which I put in parentheses and put my little negative 1 reminder. Now I'm going to clean up the top first, and we'll get to the bottom because it's simpler. The negative 1 makes a negative 5, positive 5. We're going to join with the 6 and get 11. Negative 15i plus 2i is negative 13i. That's the top cleaned up in a plus bi form. Now the bottom, remember, all I have to do is Florida. 2 times 2 is 4. 5 times 5 is 25, but a positive times a negative is negative. Then I have I squared, parentheses, negative 1. That's going to make the negative 25 positive. So I end up with 11 minus 13i. 4 plus 25 is 29. Nothing can reduce. Page 1 complete. Now you notice this looks a little bit different than yours. I just spaced it out, so it may not match the layout of your paper, but I did that to have more room on the smartboard. Okay, square root property. When we have the square root property, we want to get whatever's square rooted, whether it's a letter or parentheses. We want to get these by themselves. So to do that, I'm going to subtract 3. X squared equals 18. Now, to get rid of this 2, I square root it. And I do the same to both sides. X equals. Now, since I'm doing solutions, I always want to put plus minus square root of 18, which if I can take the step to do that now, or I could just break it on down up here and get 3 root 2. It's up to you whether you want to take the extra step or not. Square root of 9 is 3. 3 root 2. Okay, this one is already by itself. So I can just attack it. I'm going to rewrite it though, just to not have too much stuff going on. I square root, to get rid of that, I square root here. That gives me x minus 5 equals plus or minus. Again, I'm just going to do this right here. 4 times 6. Square root of 4 is 2, so that's 2 root 6. Now I'm just going to add 5 to both sides to move the negative 5 over, and I get 5 plus or minus 2 times radical 6. Okay, x squared plus 13. I need to move the 13 over by subtraction. That's going to give me a negative number. But that's okay now, because we know how to deal with negative numbers. This is going to be x equals plus or minus square root. I want to break this one down. Baby steps. Negative 1 times 4 times 3. X equals. There's my radical. The 3 is going to stay inside. The negative 1 is going to come out as an I. Square root of 4 is a 2, and then we put our plus and minus. 2i, square root of 3. factoring. Okay? A, 3, B, 10, and C, negative 8. I'm going to do my ABC method. Negative 24 and 10. Since the AC is negative, I want one positive, one negative. And they're going to differ by 10. 1 and 24, 2 and 12, I'm done. 2 and 12. Now, which one do I want to be positive? The bigger one, because I have more positives in the middle. 3x squared, again, I can write the negative 2 or the 12. It makes no difference. Let me go with the negative 2 this time, just to show what happens. Because sometimes you only pull out a letter or a number, or number 1. So minus 2x plus 12x minus 8. Obviously, the 12 and the 3 were going together than the 2 and the 8, but it's okay. You still end up with the same answer. So what comes out of 3 and 2? Nothing, just a 1. And then the x. So that's going to be 3x minus 2. But that's okay, because I can cheat and put 3x minus 2 right here. What do I divide 12 by to get 3? 4, a plus 4. Same with negative 8. Hook them up. X plus 4 times 3x minus 2. Remember though, this whole way I'm solving. So I do each one equal to 0. Subtract 4, x equals negative 4. Probably should put that on top of the equal sign, gets confusing sometimes. Negative 4. Then I'm going to add 2 and divide by 3. X equals 2/3. Remember, it's not 3 halves. If you need to take the baby steps, show it. Add 2 to both sides, 3x equals 2. Divide by 3, x equals 2/3. Okay, up here, perfect square, perfect square, perfect square. Difference. Easy, breezy, beautiful, cover girl. 1 plus, 1 minus. Square root of the first term, square root of the second term. 3x plus 8 equals 0. 3x minus 8 equals 0. Careful here. Again, you can show the word if you want. Subtract 8. Divide by 3. Add 8. Divide by 3. This one we cannot do anything yet because it is not set equal to 0. So we have to rewrite it. X squared plus 4x minus 45 equals 0. Two bad zeros. First one looked like a dot, that one looked like a 6. Now this one, I'm not going to do the ABC method because this is going to be x times x, and we're looking for two numbers that multiply to give me 45 that differ by 4. That's 9 and 5. I want more leftovers, so it looks like that. X plus 9 equals 0. X minus 5 equals 0. X is negative 9. X is positive 5. Find the value of C that makes the trinomial factors perfect square. Well, here's the cheat I taught you. So take half of 6 plus 3. Okay? Now, that's the number we're going to square to get C. We would add to both sides. And then the binomial is just finish it off, do this, boom, you're done. Okay? Half of 2. 1 squared is 1. We would add 1 to both sides. Finish it off. That's it. Careful. Negative 14. Still squares to 49, whether it's positive or negative, but it changes the binomial. So you have to be careful there. And once again, we would end up adding 49 to both sides of the equation when we do that. So let's practice that right now. We're going to move the 11 over. X squared minus 8x. Remember, we're going to leave a space. Equals positive 11. We're going to take negative 4, because that's half of negative 8. I'm just going to go right ahead and do this right now. I'm going to square 4. negative 4, and get plus 16. Plus 16. Well, see, this right here is this. That's the beauty of this. Equals 27. Now I square root, like we did earlier on the square root method, and we get x minus 4 equals plus or minus square root 27, which remember breaks down to radical 9 and radical 3. So that's going to give me x equals, jumped ahead, x minus 4 equals plus or minus 3 root 3. Square root 9 is 3. Now I just move this over, x equals 4 plus or minus 3 root 3. First step, move 25 over. X squared plus 6x, leave a space, equals negative 25. Half of positive 6 is positive 3. Just go ahead and complete this right now. 3 squared is 9. Equals negative 16. Square root both sides. And I get x plus 3 equals plus or minus the square root of negative 16, which is negative 1 times 16. Well, when I break that on down, I get plus or minus 4i. Square root of 16 is 4, square root of negative 1 is I. Now I just move this over. X equals negative 3 plus or minus 4i.
Okay, we changed this problem. Now notice that the 3 is already on the other side, so we actually have our space right here. So we just take the parentheses, our shortcut, our binomial squared, remember. Now we're just going to take x, half of 6 is 3, positive 6, positive 3. We're adding 9 here, so that means we add 9 here. And that basically just gives us equals 12. Now to undo a square, we square root. Cancels. We square root over here. The 12 is going to break down to 4 and 3. So that's going to be x plus 3 equals plus or minus, always with solving. Square root of 4 is 2, root 3. And our last step is to move this 3 over. So x equals negative 3, because we moved it to the other side, plus or minus 2 root 3. And that is our answer. That was just bad. Let's try doing that again.